Well, it sure looks a lot different than last time I was here showing you around. Remember last time? And I told you from time to time, I'm going to show videos of this house being built over here. And we're on an off day. None of the workers are here today. And they've gotten a lot done since last time I'd shown you here. Last time, remember? If you were here, I showed you before they poured the concrete, what it looked like, and after they poured the concrete, what it looked like, and all that kind of stuff. Now they've really got a lot of stuff going on. And what is this stuff anyways? We'll see this. See this? This is what I call a TJI floor joist. And it's like an I-beam. See how it's shaped like an I? Like that. And they have these look like maybe 8 inches tall, and they're designed to span X amount of feet across. Now see how long they are? That's probably, I don't know, 20 feet long. They're not going to span 20 feet long. There's probably going to be a wall underneath it or something like that. And then see, there's some other floor joists. See those right there? Look at that. That's like a truss floor joist. And they installed those down here at the bottom. See that? Look at that. Now, those were about, those may be, these here are about the same length. If not, they're shorter than those, but these over here are actually longer. I think one area is like 30 feet long, but see, there's a wall. There's a wall down there about halfway, so they're only spanning maybe 15 feet, but they ended up still making them 30 feet long, just so that they could put them up one piece at a time. Isn't that something? Those are just made out of 2x4s. See that? They're kind of made like a roof truss, except they're a floor truss. See, look, there's only one 2x4 on top, one at the bottom, and these angles like that. That's enough to span that far without it sagging and to hold up a floor. That's a floor joist. That's going to hold up another floor up above. I'm going to just walk down here. I'm going to show you some stuff. Now see, they're going to build another floor on top of that. There's going to be plywood on top of that, and then there's going to be a second story on there. And certain areas they're using that type of floor joists, and in other areas they're using the TJI floor joists, made out of the OSB plywood. So it just depends who the architect is and how they're going about designing this. See how the footings, these are stem wall concrete footings, and they go up at an angle, and there's a certain code as to where the wood stops and where the ground is going to start. There's a certain amount of distance you have to have there for grading issues, for termite issues, and all that kind of stuff. See how this one from here down to that styrofoam, is probably a good 13, 14 inches. There's one that's about 12 inches. Here's another one about 12 inches. And see, they haven't graded this yet. This is probably going to be up a little bit higher. So, it's always important to read your plans. You don't have to worry about exactly how they frame this and all that kind of stuff, because every house is different. And I thought a few things interesting that I saw. First off, you see here, look at this. They have like a foam strip where it looks like they've probably put that down underneath all of the mud sill. And years ago they didn't used to do that, but now I think sometimes they do that. I'm not sure exactly why, because mud sill plate is designed to go directly down on top of the concrete. And see, I see this piece here going to there. I don't really see anything under there unless they did it really, really super good. And another thing I noticed too that was odd, you see this 2x6 plate here? Look how fat it is. Look at that. mind you, that is at least 2 inches, 2 inches thick, maybe a little bit more. And most mud sill is about 1.5 inches thick. Now see, they put that right down on top of the concrete. When they poured the concrete stem walls here, they had these. See this? This is only 1.5 inches thick by a 2x6. That's what a standard 2x6 mud sill looks like. But see how big this one is? Isn't that amazing? That is an actual 2 inches thick, and I'm not really sure why they did that. I don't have an answer for you. Next time the builders are out here, maybe I'll ask them. And here's something else that I noticed. Where was it? Oh, okay. You see here. This is kind of called like a glue lamb beam material. For some reason they decided to use that. I'm not quite sure why they did that. That's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 2x6s glued together and attached, and it's a beam. And see, it goes all the way up to the top plate. There's 2 2x6s up at the top. You know, over here, that's generally how you build walls. You have 2 top plates. The bottom plate goes all the way across one direction, and then the top plate, this top plate is longer, and it goes over on top of the other one. Those 2 top plates, see the top plate on at the very top is cut right to the corner. The bottom plate goes all the way across. And then when you frame this wall, it's the very opposite. This 2x6 just stops there. The 2x6 up there overlaps that wall, and that's how they tie it together, see? But usually they'll run a beam, a header. See, like here's a standard header here. It just goes up, it's usually a 4x12, and then it goes up to the bottom plate. Well, for some reason, they had to do it a little bit differently because they're trying to get the elevations exactly so on how they built the concrete stem walls over there. And so when the framers came over here, they have to do a lot of measuring, so that when they build this wall here, they have to know exactly what the height is in reference to over there, so that they can have those plates over there on the wall that goes down like that. They have to have it the same height. And it cracked me up. I was talking to the owners, and they said they happened to be out here when they watched one of the kids. There's like four guys who are doing the framing out here, and one of the kids was out here by himself, and he had framed up this one wall. The next day they were tearing it down because apparently maybe he misunderstood his boss, or maybe his boss told him to do something and he added the measurements incorrectly. I don't know what happened, but either way, they had to pull this down and rebuild just this first wall, because that distinguishes, at this point down here, distinguishes the height of the plate line across there, so that your floor up here is going to be the same as the next area and the next area. It's very intricate how they do everything. It's very interesting, and like I say, not all houses are created equal. So every time somebody builds a house, you got to read the plans, you got to do some measuring. There on the plans, it didn't say build this wall X amount of height plus inches exactly, because the person who comes out here, he's going to have to be able to do that depending on what height this concrete floor was poured at. You see what I'm saying? And so everything is slightly different. So you really got to know. This is where your math comes into play. If you think you never had to use math, and then you want to go out on a construction site and be out there with, you're going to have to know how to add things, how to square up lines. So when they snap, you see the red lines here? When he snapped those lines, how does he know it's perfectly square here? Well, there's certain ways to do that. You can't just measure off the outside wall in case that outside wall isn't exactly square. Are you going to make, if this wall is off slightly, let's say if that end wall was off slightly and you measured off of there, then this wall would be off slightly. There's a way to check all that. But if you want to know how to do all that stuff, the best way to do it is to start working on a crew, and then you start learning step by step. When I first started working in the building industry, I worked with my uncle for a company that he worked for, and I started from the ground up, and I was probably, I think I was 18 when I first started. I did all the grunt work. I always wanted to know, hey, show me how to build this. I want to know how to install a door. I want to know how to frame up a wall. I want to know how to build a gutter and a downspout, and how to install a toilet, and how to do this, and how. I always got the flunky stuff. Hey, clean up all the stuff over here. Put insulation up or underneath the house. Oh, here was one other thing I was going to tell you too. Remember I said these were TJIs? And I don't know what, see? TJI. It's truss, joist, and I'm not sure what I is for. Truss, joist. If you know, let me know. But in any case, lots of times you can have TJIs built maybe up to 2 feet tall, 20 inches tall or so. And I was kind of curious initially about why didn't they just make TJIs for these long floor joists here that they made out of trusses. See how they made those out of trusses? And they're running that. Now granted, all of those trusses are going to be supported underneath, at least half of it anyways. And so I'm not quite sure why they did that, because that takes up more wood than a TJI, because a TJI, none of this is straight wood. See this? This is all thin layers of plywood and of OSB plywood. Or no, this is just thin layers of actual plywood. See that? Okay, and the middle core section is like wafer board, all kinds of shavings of wood that's all been glued together, and then there's looks like three little layers, or maybe four, and then it's dadoed, it's notched in at the top and bottom, glued in. I would think that would be way cheaper than building something like that, because they have TJIs at least that tall, if not taller, and all I could think of is, well, I don't know, for some reason the builder wants to do that. Maybe it makes it easier for him to run wires through there, ductwork under through there, through the floor, and all that kind of stuff. But see, even on TJIs, you can run electrical and plumbing pipes through it. You see here? See that round area? Here's another one. Here's another one. There's another one. See? The round bits? You just take your hammer, knock that out. You can run a wire through there, a water line. And if you have to cut it more, then you've got to check and make sure that you don't cut the hole too big or too many holes too close to each other, because then you lose the strength of this. Okay? And you just have to be mindful of that. Even if you have a tall one, let's say you have them that tall, and you need an air conditioning duct or two air conditioning ducts going through there, you've got to look at the plans. You've got to know what the codes are, because you don't want out in the middle of somewhere cutting two big old holes, and then, oh, this was for my air return, my air supply, and then you find out later, oh, instead of cutting the hole there, I should have cut it. Now I thought that interesting too. When they delivered all this wood here, they had it stacked way up high, and they've left their big old forklift here. And why do you suppose they left their forklift here? Well, for one reason, they're probably using the forklift to maneuver around in here to then lift some of those long floor joists down there. But they also, each morning, they'll take some of this if they need to, and they'll set it out on the street. But then they've been good guys about then taking it back off of the street and bringing it back on the property. That's always a no-no. You never want to leave anything on the street, okay? And it's just safety purposes and the neighbors and all that kind of stuff. Check with your HOA if you have one, or with your neighbors. You never want to do that. It's really not the best thing to do. If you had to do that for a night or something, you could put You put some caution tape around it and with some orange cones or something like that. Tell the neighbors, hey, it's just only for this one day until we can get it all loaded on the property. Okay, be mindful of stuff like that.